All right, we're back again. We have 2 talks left, and they are both going to be good ones, I think, just like all the other ones today. Been really, really amazing talks. Our next speaker, she used to work at Apple. She used to work on the Apple Music app, and now she's an iOS developer in Amsterdam, and she's a true UI development enthusiast. And that's really great because she's going to talk about how to scale our UIs across all those different screen sizes and devices we have now. I remember the good old days when there was just 320 by 480 pixels, and that was it. But now there's just so many things to think about, and she's going to tell us all about it. So give a really, really warm welcome to Janina Kutyn.
Thank you. Hi. So let's talk about building an app for every iOS device. Actually, a couple of months ago, I was on an episode of John's podcast. And in preparation, he opened up questions to Twitter so that people could submit things they wanted to hear in that episode. And a lot of questions came in about how to build apps for small screens, but also for large iPad screens. Unfortunately, during the episode, we didn't really get around to answering a lot of those questions. But there are so many of them that I figured maybe it's worth talking about. So, it's like, I'm going to say word for word what John just said. At first we just had the iPhone. That was easy. Then the iPad came around. 2 screen sizes. We could handle that. Idiom iPhone, idiom iPad. And then the iOS family kind of blew up. So now we have to handle 10 different resolutions. We used to feel pity for the Android developers, but maybe now they should feel bad for us. And in the absence of the iPhone and iPad idioms, Apple has offered size classes as a solution. But there are only 2 size classes, compact and regular. And the dimensions of every device are either one or the other. And it's quite a few combinations, especially when you start considering all the possible split screens. And what's also sort of counterintuitive is that devices like iPhone SE and the largest iPad Pro have the same vertical size class, even though they're hugely different. So the designs made for iPhone just don't translate to iPad very well. But should you even bother with iPad design? Do you need to polish your apps? Most people use their iPhones day to day. Is that good enough? Well, there are 81 million active iPad users in the States. That's about a quarter of the population. Apple has sold over 400 million iPads since its launch in 2010. The average iPad has 18 free apps and 10 paid-for apps. So this means on an iPad, about a third of the apps have been paid for. And the majority of iPad users spend more than 2 hours per day on their iPad. Also, iPad apps tend to cost more. iPad owners are less sensitive of the price and tend to have higher incomes on average than iPhone users. Not to mention, soon Marzipan will come along. That's a framework that will allow us to build iOS apps that will run on the desktop. And at that point, we will have even more larger sizes to consider. So in this presentation, we're going to go through a sample app and optimize it for the iPad. It's an app I built. I have not optimized it at all. It's called Bikini Bottom Directory. It's a tab bar controller that has 1 grid, 2 table views, 1 detail screen, and a menu screen. So let's start with the menu screen. It is invoked when tapping on the bar button item in the navigation bar on the right. And it just pushes a list with predetermined options. On the iPad, it looks like this. So not a very good use of space. It's a very small list with very short titles. So maybe what we could do here is present it as a popover. And we'll do that when the menu button is tapped. We will create a menu view controller. We will set its modal presentation style to popover. We will anchor it to the bar button item it came from, and then we will present it. And we will do this for horizontal size class, and for compact, we'll keep it the same. So now it looks like this. But when we change the size class by invoking split view, the system will decide how to change the appearance of the popover. So it will decide to present it as a sheet. And we don't want that because when we go to compact, we want it to be pushed on. So we need to listen for trait collection changes. And we will listen for it here. I'm not doing anything clever here. I'm just dismissing the popover if it's up. I'm not even handling the case of going from compact to regular. So I'm just showing where this code should live. This is not complete code. And also the view hierarchy will affect the trait collection updates that are received by each view controller. So for example, in the case on the left, the navigation controller houses a tab bar controller. So when a new view controller is pushed on, that view controller will get the updates along with the navigation controller. And the tab bar controller will only get it once the view controller has been popped off. And in the scenario on the right, the tab bar controller will get the notifications every time because it houses everything within it. So the point is, the exact behavior that you want will also depend on your view hierarchy. So we'll leave it as is, but there's a lot of empty space at the bottom of that popover. So to deal with that, we will adjust the preferred content size. So in the menu view controller, we will just calculate the size that we want based on the number of rows, and we will set it. And this will only work apply to popover, and then when it's presented as full screen, this will not apply. So there, now it's a nice short little popover. And maybe actually on the iPhone this would look good too. So let's apply it to the iPhone as well. So here, we need to get the popover presentation controller of the menu view controller. We will become its delegate, and we will implement, we'll conform to its delegate, and here we'll return none for adaptive presentation style for controller. So in a compact environment, the presentation style can either be full screen or none. And returning none tells the presentation controller to ignore compact environment and continue using the previously applied style. So in the case of a popover, this is telling the system to always display it in the same way it would on the iPad. So that's our menu. It's optimized for both iPhone and iPad now. Let's carry on with the grid. So this is in the first tab. This is just a regular grid of items. On the iPad, it looks like this. So those are a little bit large. And this was achieved just by using collection view layout, more specifically collection view flow layout. And we're subscribing to its delegate calls and modifying and returning the values we want there for sizes and for spacing. And we could also do that by assigning it directly, but if you want to compute it, you need to override the delegate methods. And here we return the size. So without doing anything else, when the iPad is rotated, instead of the 3 columns that we expect, we only have 2. And this is because the size for the items is preserved, and we have not invalidated the layout. So we need to invalidate the layout. We'll do it in view, we'll transition to size. This is called whenever we rotate the screen or when we change a split view. And of course, we can just reload the data, but that's more heavy-handed, and invalidate layout just flags the layout for invalidation, and it will be updated the next drawing cycle. So this means you can invalidate layout multiple times in the same block without causing multiple layout passes. This also means that even though in this method the size of the U is not our final size, by the time the layout will be invalidated and redrawn, it will be the final size. So now that we fixed that, this is what it looks like on the iPad. And we wanted to do a variable number of columns. So collection view does not support number of columns, but it does support different classes, different sizes for your items. So we're going to calculate it based on the number of columns we want. So for compact, we're going to do 3, and we're going to do 4 for regular size class. But then when I open an iPhone SE, maybe those cells are a little bit small, but we only have compact and regular. What can we do to deal with that? I like to roll out my own version of size classes. I usually make an extension in UI window. I create a size category, and I define those categories based on this specific app needs. So in this case, the extra small will be like the small iPhone, extra large. Large will be iPad Pro, and everything else will be based on the trait collection. Or you can be more explicit with the intervals. And being explicit like that not only gives you full control and deterministic behavior, but it also lends itself nicely to Marzipan, as on the desktop, the user should be able to make the window any size they want. And this is somewhat similar to how websites handle responsiveness through CSS media queries. And so then now when we're using this in the code of the collection view controller, we key off of the size category, but we can use it for anything. We can use it to determine the class for the collection view cell or anything else you want. So now this is our grid with every device having a completely different number of columns. Okay, so let's carry on with the list on the iPhone. So this is just a regular table view. And it looks like this on iPad. So what I think could be done here is it would look nice if the table view was like double column on the iPad, which of course table view does not support, but we can use collection view for that. And in their human interface guidelines, Apple recommends using collection views for grid-like and image-heavy layouts, and to use table views when you want to display text. But there's no other way to get multiple columns, so we have to use collection views, and Apple does this in their apps like Music and App Store. Unfortunately, this means rewriting the whole class as a collection view and rewriting collection view controller and rewriting the cells. That shouldn't be too much work. But here, I've just replaced the table view collection view. I've made a class called collection table view cell, which is a collection view cell that looks exactly like a table view. I've given it all the same properties as a table view cell. And then once again, we need to conform to UI collection view delegate flow layouts. I haven't done anything special here, just made it the same as a table view. And it looks arguably a lot worse than it did at first. But now we're going to modify the flow layout. We're going to compute the width based on the number of columns. We're going to add some insets. We're going to provide a line spacing size of 0 because we want the cells to be one on top of the other, and a little bit of extra padding in the middle. And that looks like this. That looks pretty good, but we don't want 2 columns on compact trait collection and compact size class, so now we need to key off of the size class and specify if we want 2 or 1 columns. Yeah, so this is what it looks like now, pretty good, but we don't get to do the happy dance yet because on the split view on iPad, it looks like this, and I don't think that looks very nice. This is because it's regular size class. So we could use the same categories we came up with before, or we could override the trait collection for the screen size. So for that, we will create a container view controller. We need this because a view controller cannot override its own trait collection, but it can override its child's trait collection. So then we will pass in a view controller, we will add it as a child, and then we will figure out what we want the trait collection to be for any specific size. So here, I'm creating a size class that if it's 700 pixels or smaller, we're going to do compact, otherwise we're going to do regular. Now our override trait collection is going to have that size class, and we're going to pass that trait collection to our child. And now we need to actually call those updates. So we're going to do this on trait collection to change, and view will transition to size. And trait collection will change, will take care of our initial size, and view will transition to size will take care of all the other updates. And if you assign a size, a trait collection has been assigned before, the view won't get a duplicate callback, so it's fine to call this as many times as you want. And now, of course, for the tab bar controller, the controller class that we set is our container class rather than our original class. And so now this is our optimized list. So next we're doing the last tab, and that's the list with detail. So this is, once again, a table view, and when you tap on one of the cells, it will take you to the view on the right. On iPad, this, again, looks like this. And this screen, the detail screen, looks like this. It's pretty bare. So I think the perfect element for this would be UI split view controller. So on iPad, this is going to be 2-column display. And on iPhone, this is going to, out of the box, just push the detail view controller into the navigation stack. And we don't need to do anything for it. It will just handle it on its own. But back to our view hierarchy, first thing we have to do is change it. So the view hierarchy that this app currently has is the one on the left, where we have the navigation controller in which the tab bar controller lives. But split view controller cannot be embedded in a navigation controller. If it's embedded in a navigation controller, the nice navigation behavior that I just described, that is broken, and you can't use it anymore. So we need to change our view hierarchy to look like this. So now the tab bar controller is our root, and it houses the split view controller. This, of course, means that we need to go back through all the other tabs and update them to have navigation controllers of their own. So let's carry on. This is UI split view. We're going to create it like this and set its display mode to all visible. This means that the system will put 2 view controllers side by side in every single scenario unless it really, really does not have enough space. Then we're going to play with some of the properties to make the columns wider or more narrow. We also need some sort of a mechanic for the master and the detail to communicate with each other. So in a separate class, I've created the selection delegate, and this is how they're going to talk to each other. And lastly, we just assign the view controllers. I'm embedding them in navigation controllers, but they don't have to be embedded. So this is what it looks like. We barely had to do any work, and it just worked out of the box. I think UI split view controller is a great element. It offers a lot of optimization, and it's often overlooked. I've worked on projects where there have been split view controllers that have been rolled out by the developers themselves that weren't actual split view controller, but effectively perform the same function. And as a bonus, this actually also works automatically on larger iPhone screens too. So the system decides for us when to show the view controllers side by side. But there's an issue. When we're running this on the iPhone and we open the tab, the first screen we see is the detail screen. So we don't want that. We want to see the list first. So then we need to assign ourselves as a split view controller delegates and conform to that protocol. And we need to return true for split view controller, collapsed secondary controller onto primary view controller. It's a mouthful, but basically this method is just asking, when going into compact size, do you want the secondary view controller to be collapsed onto the primary? In other words, do you want the detail to be discarded and only the master to be shown? And I'm saying yes here because when launching an iPhone in compact, I always want to show the master and I don't care about the detail. But the knock-on effect here is that when going to compact from regular size class, the detail will always be discarded. We may not want to do that, so some more logic needs to be added. For instance, in the built-in master detail template in Xcode, they check if the detail view controller already has a model object and discard it if it does not. So you could do something like that. So now this is the right screen when we launch on the iPhone. But when we tap on those cells, nothing happens. So that's because we haven't handled the cell selection. So now we're going to handle it. So when the split view controller is collapsed, we're going to just allow it to show the detail view controller however it wants. Otherwise, we're going to use that delegate I mentioned before to communicate between the master and the detail. There, so that's pretty much done. And now all we have to take care of are the disclosure indicators, or the little arrows in every cell. Because we don't want them there when we're in non-collapsed mode. Okay, so, sorry, it's distracting because this guy's sleeping. Saw you. Well, I hope I'm not boring anyone else. So here we have we're gonna have a computed variable for the preferred accessory type. If it's collapsed, we want the disclosure indicator. Otherwise, we want nothing. I'm going to need to hide that disclosure indicator. We're going to do it in 2 places. We're going to do it when view will transition to size, and we're going to do it in table view cell for row at index path. But we have view will transition to size, but we don't have view did transition to size. And we want to hide the accessory only when our view is in its final state. So we're going to take the coordinator, we're going to wait for it to finish, then we're going to set the accessory type, and then we're also going to set it for the table you sell. So there. Now our list looks perfect on both iPhone and iPad. But back to the detail view. So this is something that happens to me every single time. I don't think I've worked on a single app yet where I haven't done this, where I've taken the designs, they were probably for iPhone 7, iPhone 8, made them perfect, took great care for them to be pixel perfect, only to then open it on iPhone SE and realize my content is cut off and I had not had the foresight to put in a scroll view. Like, this happens to me literally every time. Maybe next time I work on something, I'll think of it first. So now what we need to do is embed all our content in a scroll view. So this is how it was originally. Now we're going to put it into a scroll view. And not only are we going to put it into a scroll view, we have to put a container into the scroll view. And that container has to be pinned by all sides to the scroll view. It also has to have the width and the height. They're the same as a scroll view. And the most importantly, it has to have the height property as low priority, so that the content can be intrinsically sized. There it is. This is that same screen mid-scroll, so it worked. But on iPad, I would say this is looking a little bit bare. So let's go back to Xcode and use trait variations and interface builder. This is a kind of a cool feature. What you can do is you can select any type of variation. So here I'm selecting regular width and regular height. And for this, I will want to add something new. So I tap on Vary for Trait. This will allow me to select either the width or the height or both. So I'm going to do both. So every time, every screen that's going to have both width and height as regular is going to get my variations. Then I double-click on the constraints that I want to edit, and I add the values that I want them to have in this case. So here I'm having a larger image view, and it's positioned a little bit lower from the top. But not only that, I've even added a brand new element, so a UI button, that will only be there for regular width and regular height. And as you can see on the right, this is compact width and regular height. It doesn't have it. I should mention, though, that in terms of adding new elements, this works. But if you try to modify the positions of existing elements beyond the constants of constraints, that's not going to work. So for instance, if you wanted to put the stack view next to the image view, you can't do that. But you can specify variations for all sorts of traits. You can do it for fonts, for images, for colors, etc. So now our detail screen is looking pretty good. But that was a lot. I feel like an alternative title for this presentation could have been 1001 Ways to Use Trait Collections. So let's wrap it up. So I think before you start building an app, it's important to think about the different variations of your design. Early on in the process, how should my app look on an iPad should be one of the first questions you ask, not one of the last, if you want to support iPad. You should approach your app development holistically. I wouldn't have had to write my entire app architecture had I thought about how every screen should behave before implementing. I would have thought about that split view controller, and I would have known not to start with a navigation controller at my root. Also leverage UIKit components. From popovers to trait collections, UIKit offers so much support for achieving beautiful adaptive apps. One more. And explore the edge cases. Don't leave it till the very end to run your code on iPhone SE like I did. Check out how your app behaves when rotated in split view or in split view early on to save yourself the headache later. Thank you. All right.